All right, so going back to the inner loop and the outer loop. So I'm showing that arrow slide again, and this is a really popular slide that we like to use to help articulate this. But when you focus on the inner loop, Aaron just played the role of the developer, and he's got a couple steps in the inner loop that he can go through. So the first of this is discover and start. So this has the API portal where he can discover all the APIs that are available to our enterprise. We haven't demoed that today, but there will be a demo video that we'll have out shortly to kind of walk you through that. He did go through the app accelerator. So think of this as Aaron getting started building a new application rather than starting from scratch. He's just stepping into what we call an accelerator, which is a scaffold for a new application. So he's able to pull that down and get started really rapidly rather than just starting from scratch every time. One thing to note about these app accelerators that I think is really important, and we found really good feedback from our customers so far, is that we provide a lot of them out of box, as you were seeing when Aaron walked through them, for a variety of different application types as well as languages. But those are fully customizable by your organization. So you can have your enterprise architects, your security teams help and build those accelerators so that they have your organization's best practices, architectures, those type of things in them. So when a new developer comes on board, they're able to pull those accelerators down and get started from scratch with all of your organization's best practices in them. Inside of that inner loop as well, which is what Aaron was demonstrating, is you can iterate. So he deployed an application and got it up and running. And then he then made some code changes, which did a live update out to his remote cluster, and then was able to test that on a cluster that will mimic production. And then finally, you can do debug, and we didn't demo that today, but think of it as a developer, you're setting breakpoints in your application, and you can step through your application to look at values and those type of things as you're testing it out and trying to troubleshoot maybe an issue that has happened. So that covers the inner loop. From an outer loop perspective, it's really all about supply chains, right? So it's taking that source code that Aaron just built and compiled and getting it shipped out to production so that we can get that out and running with little to no involvement from our operations teams or development teams. And it's following a pre-approved path that our operations and security teams have defined that follows your organization's best practices and standards to get that code deployed, right? So it's basically taking source code, getting it to a URL or a running application using the path that you typically have as part of your software development lifecycle, right? So I hope that covers a little bit more in detail of the inner loop and outer loop. I'm going to go into an example of a supply chain here in just a second that's going to kind of walk through how you define those and how you build those and what it'll look like. So I think I've covered in the inner loop and outer loop, I've covered really well the kind of the roles that we have identified and established, and we do our best to make sure that there's a clear separation between dev and ops. One of the things that I think is really important to talk about is how we hand that handoff between dev and ops, right? So typically, if you're used to this type of relationship, you can see a throw it over the wall mentality happen pretty frequently, which is developers and operations don't talk or communicate or collaborate until the application's completed and it's time to get it deployed. And then it's just a mess trying to get things deployed because they haven't agreed on things like where it's going to run, what environment variables they need, configuration differences. So one of the things we really focus on is easing that handoff. And when I'm talking about easing that handoff between dev and ops, there's three things that I really like to look at to promote a successful handoff. And the first thing is consistent clusters. So Aaron talked about it a little bit, but as part of the Tanzu application platform, we like each developer to have a personalized develop environment. And he talked about it a bit, but this development environment can be something from, Minikube or Kind running on your local laptop to something like a on-prem Kubernetes cluster that might be running as part of vSphere, or even, a cloud Kubernetes cluster that's running as part of a managed cloud service. But the nice thing about having, the ability to deploy to a remote cluster is, as an operations engineer, I'm able to then make that development cluster look and feel very similar to what the application is going to look like when it runs in production. So you can remove a lot of those environmental variables that you typically run into that always causes problems as part of getting a application deployed from development to production. The next item is doing repeatable container builds. So we talked about it a little bit, but we leverage the Tanzu build service as part of our supply chain, which produces a repeatable container build between dev and prod. This isn't something that a developer is building locally and then we completely redesign the container design once we go to run it in production. the Tanzu build service is part of the supply chain in the dev supply chain, and it's going to build a repeatable container image so that that process is going to be exactly the same, and the container will be exactly the same as it moves from dev to prod. And I'll go through that a little bit more as we talk through the supply chain. And then the final item is using the similar Kubernetes conventions. So the nice thing about the Tanzu application platform is it gives the developers the ability to run the application in a consistent manner, and a consistent runtime configuration is what you're going to get in development as what you're going to get in production. So this removes the need to do things like Docker Compose, which can give you a completely different environment than what you're going to get once it's going to be running in production. And as a former DevOps engineer, this was one of the things that plagued us immensely, was dealing with different runtimes like environment configurations, environmental variables, those type of things as we move from dev to prod. And it always seemed to get us, and it always seemed to be the most difficult thing to troubleshoot and the most difficult thing to figure out. All right, so now that we've kind of talked about the handoff, let's talk about the supply chain and how we're going to take that source code for the Spring Sensors application that Aaron built and get it deployed out into production. So the Tanzu application platform out of the box comes with 3 different supply chains, and the one that we're going to demo today is the test and scan supply chain. So basically what this is going to do is it's going to allow us to pull the source code down that Aaron has created, and we're going to run a Tecton test on it to do our CI test to make sure that it passes all of our CI tests before we move any forward on the supply chain. It's then going to pull that source code down and it's going to scan it for any vulnerabilities. So we'll take a look at that and we'll see how it scans it and look at the results. Once it has passed the scan and it knows that it's not violating our security policy, we're going to enter the Tanzu build service and we're going to build our container image for our application, which again is going to be using a repeatable build process similar to what we used on the dev cycle. Once that image is built and pushed to our registry, we're going to scan it for any vulnerabilities, again, checking to make sure that it does not violate our policy so that we can move forward with the deployment. And then finally, we're going to generate the quote unquote wall of YAML that is typically associated with the deployment and minimize that so that it's dynamically generated by the Tanzu application platform. So your developers and operators don't have to think about it. It's dynamically generated based off of the results of the build, so the metadata that's attached to that image based on application type, what type of workload it is, those type of things. And then it's going to be deployed out to cloud native runtimes and running using cloud native deployment patterns, which we'll show a few of those. All right, I can pause here real quick before we get into the demo. Is there any pressing questions there to make sure that everything's clear before I start demoing? Or do we want to hold them to the end?
I think we can keep going with the demo.
Okay.
You're right. We have a lot of questions, so we can continue with the demo.
That's exciting. Thank you, everybody. Keep them coming. Keep it interactive. All right. So kind of as Aaron showed earlier, I'm just going to I'm going to walk through here, and we're going to show that that we're not running anything in our cluster. So you can see here that we have nothing running. I'm going to take that source code. You can see I'm already in the repository. So I pulled that code down that Aaron just built and committed. I'm in my Spring Sensors application. So let's go ahead and build a workload. I'm just going to do a Tanzu app workload create, and then we're going to specify that workload.yaml file that he built. And one of the things I want to show here is that this is the code that came from, or this is the workload.yaml that came from the accelerator with just a few modifications. So you can see we've added a has tests flags, which is going to direct the Tanzu application platform to run the Tecton pipeline tests so that it can test it before moving on to the supply chain. We also added a part of label so that it'll know when I get into the Backstage catalog that it's part of this application, and we'll show that here as we get towards the back half of the demo. So I'm going to go ahead and create this, and while that's going, one of the things I also want to point out is that this is all the YAML we have to deal with, right? This is 22 lines of code for the YAML. So it's very, very simple compared to what you're typically used to and have in order to get something deployed out to Kubernetes. So as that supply chain walks through, I find the best way to watch it go through is just to watch the pods as they're being spun up. So let's take a look at those pods. So I'm just doing a simple watch kubectl get pods, and you can see that our testing pod has already launched and it's 20 seconds into running. So let's take a look at that. So let's do a klogs follow. You can see that it's already testing, or it's already downloading and building the application so it can run the test. Let's just look at this real quick, though, what it's doing. So it's basically just pulling our source code down, and then we're running a basic Maven test so that we're going to use the Maven functionality to test our our application, and we should be almost finished, if not finished already. Yep, so it's building. Here it's going to execute the tests. This is a very simple test. We have one test running, so here in a second, we should see that we have finished. Yep, so we have one test that we've run, no failures, so we're going to be allowed to continue on with the supply chain. I should mention here too that the test pipeline is completely customizable. You're able to adjust it and modify it to the way that you see fit. Let's see where we're at. Okay, so we have now started our source code scan, and this will just take a second. So we'll hop through the vulnerability results here in a second, but this is actually pulling our source code down, scanning it for any vulnerabilities. Okay, cool. So we see that the scan has completed, and now we've started off we've kicked off a build for that pod. So let's look at the KP build logs, and I'm going to do Spring Sensors. All right, you can see that it started building the application, and again, this is using the Tanzu build service, and I'm going to cancel these logs off because I think it'll be good here to kind of walk through this so you can see how this is working. So when the Tanzu build service pulls, or when it starts, it's going to pull down the source code for our application. So it's pulled down that source code, and then we're going to use what's called cloud native build packs. Now, the cloud native build packs are going to help us build our container image in a repeatable and consistent and secure manner. And the way that it does that, you can see that we have 19 build packs that are participating in this build. It's going to execute each of those 19 build packs against our source code and look for signatures that are present in those cloud native build packs to determine if it should run. If it determines that it should run, it's going to execute against it and build the container layer. And at the very end, it's going to compile all of those layers together in order to build our container image. And this is really nice. Again, as a former DevOps engineer, I've spent way more time building Docker files and building images than I care to admit. And it's something that I wish I never had to do, and wish that I had that time back. And the nice thing about this is, without having that Docker file, we're leveraging the open source community that's building the cloud native build packs to build to use the best practices in security, configuration, architectures, all of those type of things in order to build our applications container images. So you can see here it detected 9 build packs. We know that this is a Spring application, so it's got Spring Boot, and it's also wrapped in Maven, so we're using Maven, and then served up with Apache Tomcat. So it's going to use all those build packs to build our container image. All right, let's hop a look. It should be finished now. Yep, so we finished. So the build service is finished building our image. And there's a couple of important things here to point out. So one, it's pushed it up to our registry, so it'll be able to pull down when we enter runtime. The other important thing I want to point out is that we're also signing the image using Cosine. So this is important because, one, we want to trust the container image. We want to validate that it hasn't been modified since we pushed it up to the registry. But the other important thing that I want to point out is that the Tanzu application platform has a admission webhook in it that you're allowed to configure, and you can actually configure the platform to not allow any unsigned images to run on your Kubernetes cluster. So again, just raising the level of security that we can provide with the application platform. All right, let's hop back out and see where we're at. So now we can see that we have a second scan pod that has gotten kicked off. And this is actually pulling down the image that the Tanzu build service just built. And it actually ran a source code on, or an image scan on it using the Gripe scanner. So let's take a look at those results. So I'm just going to do a kubectl get image scan. Let me clear this so it's a little bit easier to see. Okay, so we can see that we've completed our image scan. So let's dive down into that a little bit more and examine the details. Oops. Okay, describe. Cool. So there's a couple things I'd like to point out here. So the first thing I want to point out is that it has completed the scan successfully, and it did find CVEs. It found 31 total CVEs, 8 medium, 23 low, but none of those CVEs actually violated our policy, which we'll look at here in a second. But basically, nothing violated our policy, so it's going to be allowed to continue on the supply chain. Also, the results were sent to our metadata store. So the metadata store is where we can send results to, archive them with enriched data so we can take a look at them in the future, or we can just get a better look at it if we wanted to see what CVEs were actually found and associated with what packages. Okay, so let's go ahead, and now that we've done that, let's take a look at that scan policy. Get scan. We see we have one scan policy, so let's go ahead and take a look at the details of that scan policy, so I can show exactly what our policy is set to, so we can know if the supply chain was going to be allowed to continue. So you can see right here, I'm looking at the scan policy that we have defined for our platform, and we can see that anything that is a critical, high, or unknown severity is going to violate our policy, which basically means if we had anything that hit that, it's going to stop the supply chain right there and not allow you to continue. This is big because this shifts your scanning left, and it helps prevent and move into a proactive vulnerability remediation versus a reactive remediation when your application's already out there and sitting vulnerable. So now that we have looked at that and we know that we have passed the policy, let's take a look at it from the metadata store. So the metadata store, as I mentioned, is going to provide us with enriched data on the scan results. It's also going to give us archived view of it, so we can go back and look at previous results. So in order to look at that, I'm going to grab the SHA of the image that was created. Let's do an insight image get digest. Take a look at that. So you can see here that the results show all of the packages that were installed in that container that we just built and any of the CVEs that are associated with that container build. So let's assume here that we are really interested in this GCE vulnerability, and specifically our security team wants to know our exposure across all of our applications that have this vulnerability. So from here, we can just do a insight vulnerabilities, and bear with me because I always mistype this word. CVE. See? Site vulnerabilities. Okay, we're going to copy and paste it. All right, so now you can see all of the images that have been produced that had this vulnerability in it. So we can get a historical view of all the images and know the exposure to our CVE. All right. So now let's take a look at our pods. So we've completed the scan. We've looked through all of the results. We can see that everything from our supply chain is completed. Let's take a look at the workload. So we can see that our workload is ready, and we can dive into this deeper. So do Spring sensors. All right, cool. So we can see that it's working, we can see that it's ready. We see that the workloads, pods that are available, and we also have been given a URL to access our application at. This is cool, but before we actually access the application, let's hop over to the Tap GUI and take a look at it. So when I hop into our Tap GUI, and again, this is the Backstage component from Spotify, this is going to be our catalog. So this is the catalog that our organization has defined of our application. So I can dive here into my Spring sensors. This is the application that Aaron just built, and now we've deployed through our supply chain. We get all sorts of metadata about our application here. So I can see the owner, where it's at in the life cycle. I can also hop out and check out the source code if I want to get a direct link to the source code. I also can view any tech docs from here. So if I had any documentation that I thought was pertinent and wanted to expose, I could do that as well. What I think is really cool here is we can hop into the runtime, so we can actually see the Knative service that was deployed. We can see the URL, which we'll come back to in a second, the status of all of our services, the hierarchy of all of the components, any metadata about the service, so the annotations, labels. We can see the routes. So if we had one route or multiple routes, we'd be able to see that. And then any of the revisions of the application that we have deployed. Now here's the important part, and part that I think is really cool. So if we come down here and we see pods, we can see that there's 0 pods available, which doesn't seem right? But we also talked about earlier when we deploy and we run it, since we're using cloud native runtimes in Knative, we have access to some of those cloud native deployment patterns. And this is one of those patterns that we have. So when we deployed it, we scaled it up automatically, but we haven't actually sent any requests to it. So cloud native runtimes actually said, hey, I haven't got a request for a while. Let's go ahead and scale down our pods to 0 so that we're saving resources and saving our customer money, right? So what's going to happen here is if I actually go up to the URL, you're going to see that it's going to start to pause for a second. And the reason it's pausing is because CNR is actually holding on to that request that has come in. And in the background, it's launching a new container. So you can see that we have a deployment running, and it's only been running for 8 seconds. So by the time I hop back, we can now see that our application is up and running and it's available. So we have successfully went through our entire supply chain, and we've defined that supply chain as an operations team such that it's following our organization's best practices in our typical deployment lifecycle. Now, what's really nice about this is by creating that initially, this is the last time as an operations engineer that I'll have to touch it unless if I want to make any modifications. So anytime now that Aaron goes back and makes any modifications to his source code and commits it, and then it gets merged, peer reviewed and merged into the main branch or whatever branch we specify, it's going to run through that supply chain again. So there will be no involvement from the operations team, and it now removes your operations team as a burden to get applications deployed from your developers into production. So with that completes the demo.